The TLDW. We used just two resistors to get another video card to work by fixing the PEX RESET and power-up sequencing circuits. Stick around if you want to hear the entire tale of the revival of this card, a reference design Radeon that is running in my PC at the time of writing. I don't have a tree in my backyard that grows defective graphics cards, so, unsurprisingly, the adventure starts with the auction site. The ad was for a bundle, a dead GTX 770 and a dead HD 5770, both of them sold for $10, shipping included. I reviewed the GTX 770 and the board is still due for a fairly long repair video. Make sure you get subscribed not to miss it. But this video is about the Radeon. My initial inspection was superficial, and you'll see why later in the video. My notes for this repair have written down nothing unusual. Boy, was I wrong. Resistance measurements didn't reveal any issues. The input 12 volts and 3.3 volts on the PCI fingers didn't reveal any shorts. Measurements between various coils and ground did not point out shorts, and the GPU measured in the range of a few ohms. All was good, so I powered up the card to measure voltages. The fan went off at almost 100%, the GPU voltage measured 0 volts, and I got no image. Things got interesting on my second visual inspection. This happened after I fixed the DDR4 GT1030. You should get a link popping up about now, or you can use the one in the description. And lo and behold, much like with the DDR4 GT1030, the PEX RESET circuitry of the Radeon was also badly mangled. What are the odds of getting two cards with the same issue? Anyway, judging by the state of the PCB, this board did have, at one point, an AND gate to buffer the signal. But now, the gate and the pads it was connected to were missing. Fortunately, the pads for the alternative circuit, a 0-ohm resistor to connect the reset directly to the GPU, were still there and in good shape. I asked the donor boards for volunteers, and the brave GTX 960 took a step forward, I think. I first searched for a 0-ohm resistor in the schematics of the 960. Next step was to locate the same resistor on the board and measure it just to be on the safe side. A bit of flux and a bit of leaded solder on the pads, and I was able to easily push the resistor off the donor board. I used the same mechanism to tin the pads on the HD 5770. I then added another drop of flux to be able to float the resistor in place and solder it down using hot air. I then used the multimeter in diode mode to check the voltage drop between the now connected PEX RESET line and ground, and the reading was fine. I quickly strapped a small heatsink on the GPU and slotted it in the mining adapter. Did a quick review, made sure that I connected everything, I then powered on the PC. The PC did one boot loop, so I quickly went to look at the monitor and I got beeps. And no image. Measuring the GPU voltage, it turned out to be still at 0 volts. Memory also showed nothing. At this point I pulled the schematics for the 5770, and from what I could understand, the power-up sequence starts with the GPU core. VDDC and VDDCI and memory would come up after. This could mean that fixing the core power could potentially fix the card. So I started looking at the schematics for the phase controller, trying to find an enable signal. It turns out that the enable is performed by making sure that a number of transistors stay blocked, so that the internal pull-up resistor brings the enable signal to a high level. Looking at the power-up circuitry, Q1008 is the final stage at detecting the presence of 12 volts at the PCI connector and 12 volts at the external power connector. Q1012 is the final one responsible for detection of 3.3 volts at the PCI fingers, but also for the 12 volts external connector sense pin. And lastly, Q210 is the third transistor that can pull down the phase controller enable in case of extreme thermal conditions. Having this knowledge at hand, literally I was swiping through these slides on my phone, I powered up the card again and started measuring. As suspected, the enable signal was low, meaning one of the mentioned transistors was conducting. To see which one, we measure the voltage on the bases of these transistors, and the one conducting should have at least 0.6 volts on its base. Base of Q1008 measured well below 0.4 volts, so it was off the hook. But the base of Q1012 measured 0.7 volts, so we now know which one is open. And according to the schematics, this can only happen if the base to emitter voltage for the transistor that precedes it, Q1017, is too low to open it. And measuring the base of Q1017, I got 0 volts, like the 3.3 volts line was not there. But the 3.3 volts from the PCI fingers was there. It was readily available at the VBIOS chip. So what gives? With the card powered off and removed from the mining adapter, I measured the resistance between the base of Q1017 and the 3.3 volts input. And let me tell you, it was not the 2.3 kilo ohms as the schematics points out for the R1029. I then started to look up the mentioned resistor on the PCB. I managed to find the label on the silk screen, but then all I could see close to it was a pair of empty pads. I was baffled. So far this card was missing the AND gate for the PEX reset, and now also a resistor in the power-up circuitry. Could that happen by accident? Was this card used for parts? Despite not having an answer to these questions, I decided to press on. Taking into account the role of Q1017, any value between 1 kilo ohm and 2.7 kilo ohms for the R1029 resistor would probably do. On the schematics of the GTX 960, I found 2.2 kilo ohm resistors in the DVI output circuitry. Our old volunteer donor board obliged, and I was able to lift the resistor from the PCB. Using the same drop of flux to help positioning components technique, I tinned the pads on the HD 5770, then placed the resistor and soldered it in place using hot air. Back with the temporary heatsink and card slotted in the mining adapter, I now had one question. Will it power up? And yes, it does. With the card reassembled, I then launched Heaven and GPU-Z, and both provided the expected output. Valid specs in Tech PowerUps app, and a nice 3D render in the Unigine powered benchmark. This card came in with a few components missing, all on the back of the PCB. While I can see an accident happening that would knock off the AND gate for the PEX reset, I'm not sure what to think about the missing resistor R1029. But hey, maybe some things are best left unexplained. Make sure you get subscribe. And lastly, Q210